All right, so this is the third part of the first lecture on Introduction to Prompt and Context Engineering, about some key concepts of tokens, inference costs associated with tokens, usage, context windows, hooks, all these terms like rate limits, temperature. Didn't understand until I had time to sit down and study them, and this is what the man with one eye has found out to tell you. So in artificial intelligence, a token can be a word or part of a word, or even punctuation or mathematical symbol. On average, one token is about 4 English characters. Obviously, comes in Chinese characters and other things as well. So hello is 1 token, although it's 5 characters. Exclamation mark is a token all by itself. And anti-disestablishmentarianism, which is one of the longest words in the English language, is multiple tokens. Anti-disestablishmentarianism, according to Claude. So tokenization is based on methods like byte pair encoding. This is a method going back to the 1990s, a bit like the, let me just get rid of this. You can see all the different versions. I keep correcting typos. So yeah, byte pair encoding. It's an algorithm for encoding strings of text into smaller strings. So it's a little bit like the ASCII characterization, but that's per character, whereas this is for strings. So just like ASCII converts into bits and bytes, so do tokens. They consume memory. On average, 1,000 tokens, which is about 750 English words, is about 4 kilobytes of memory. So you want to manage the amount of memory that you're using. Not only that, if you're a professional developer or business, then you pay per token in a way I'll explain in a minute. So you want to have token efficient prompts like explain in detail, rather than please could you kindly provide me with a comprehensive and detailed explanation. You may think that's an efficient prompt, but actually it isn't. We don't have to say please or kindly. And comprehensive and detailed. Well, detailed probably covers comprehensive. You know what I mean? You need to trim the fat and just have the essential words in your prompt. And when you're giving examples, so helping the model to learn, make sure that you make good use of tokens. Provide very different examples, not the same. So strategically chosen examples. And if you've got long conversation histories, we'll explain in a minute how the conversation history is carried with every time you make a model call. That's how the model actually remembers. So you may want periodically summarizing context so that you don't have to keep very long conversation histories, because that's token heavy. Similarly, your instructions, they don't have to be very, very detailed. Just make them clear and concise, because every token costs money and energy. Efficient prompts not only mean the cost to you is lower, the responses are faster, but it has less environmental impact as well. So every token used, whether it's from the inputs or the completion tokens, those are the tokens used for compiling responses, including all the searching of the internet and this sort of thing. These completion tokens can be quite considerable. This adds to what's called the inference cost, which determines the charges, not to people like probably you and me, the pro users, rather than the coders and professional developers or businesses, but users of, for example, the OpenAI API platform or other LLMs for developers and businesses, people that are using LLMs that want to integrate into their apps or their work environment, they are charged according to the inference cost. So if you've got longer prompts or repeated model calls, sort of same thing, the same thing, only slightly differently again and again, that can result in higher charges. You need an optimized prompt, preferably to a custom-built LLM, that will reduce your inference costs and energy consumption and improve the quality of the output at the same time. There's some new management called context window management. It's about deciding what information stays in the room. You'll see what I mean when I explain what a context window is. And with context window management, you need to balance the inference costs from the system instructions, from the user input, from these things called hooks, and the desired output that you want, to make sure that it's not too verbose. So completion tokens in particular, they're going to depend on the tone or the temperature of responses. And they can take up a lot of the inference cost. But what do I mean by temperature? In AI, temperature controls the randomness of the responses generated by an LLM. And it affects how likely the model is to choose improbable words, unusual words. So a low temperature is pretty deterministic, very focused. It'll always choose the most likely word next. It's a bit boring, but it's good for logic, maths, fact-based tasks. Medium temperature, you might call balanced creativity. That introduces some variation. It's good for explanations or rewording. But if you want some really creative and diverse responses, that's when the temperature is high. You'll get much more randomness, you'll get more novelty. Every time you ask the question, you'll get something completely different. It's good for brainstorming and storytelling, but it's very token heavy. So managing the temperature is like tuning the model's imagination dial while keeping the costs at a suitable level. Now, key concept, context window. Every new prompt in a conversation initiates what we call a model call, which includes previous messages, the prompt and the response history in the conversation. That's how the model remembers. All the previous prompts and responses are sent with the next prompt in the model call. So the context window is how much text the model can see at once in any model call, including the conversation history, but also the embedded hooks. We'll explain what hooks are. They're sort of external APIs or documents, and we'll explain that in a minute. So the conversation history, any embedded hooks, your current prompt, and the LLM's response all come into the context window. And there are limits on the size of the context window. For example, per model call, GPT-4 Pro and Plus can process 128,000 tokens. Or per call, Claude 4, also the free version, but that has very strict rate limits, so won't last very long. But it has a 200,000 token context window, which is pretty big, but not as big as Gemini Pro version. It can process 1 million tokens, as that has the biggest context window. Perhaps it's a bit excessively large. Any model call whose token count exceeds the context window is going to slow down the response because it's going to forget stuff and it'll have to think harder. And so earlier prompts will drop out of the context window. They're no longer sort of remembered and they can't be used for the response. So here's a visualization. Suppose you've got a prompt and response, PNR1, which is 500 tokens. A prompt, I'm not thinking about any hooks here or external documents or things like that. The prompt and response 2 is 800, prompt and response 3 is 1,200, and the fourth one is 1,500. So the call is, to begin, 500 tokens. Then 1300 because the call sends the PNR1 for the PNR2, and so on and so on. So it's cumulative number of tokens. And if the context window is 4,000 tokens, then all these messages fit and it's fine. But if the context window is only 3,000 tokens, then message 1 gets forgotten from call 4. So the model literally cannot see the information that falls outside the window. Earlier inputs are discarded, but they're often the crucial ones, the ones that set the tone, or gives examples. And if these are forgotten because the conversation has grown beyond the context window, you're not going to get such efficient follow-up analysis. It might even be blocked because I can't remember important information at the beginning. And the session can just deteriorate and lose continuity. And you get frustrated, like, well, wasn't there anything? It's because you've exceeded the context window. Now, what are hooks? Hooks are implementation mechanisms that connect your LLM to external resources or behaviors. They include also the instruction hooks, the system prompts that persist across conversations. So in that way, it's not exactly an external resource, it's a behavior. The others are external. Tool hooks are application processing interfaces and functions that the model can call, like maps, APIs or payments, these sorts of things, functions. And then there's file hooks, databases, documents, whatever the model can access. And you can restrict those if you want. And then there's these real-time data sources, weather, stocks, and news. Actually, perhaps in this toolhooks, I should just say functions the models can call, because APIs are down here. So hooks reduce the need for lengthy prompts because the context is already established. And that's going to save tokens, it's going to reduce the costs, and will improve the consistency of the responses. If they're always referring to the same databases or documents, then you know you'll get more consistent responses. Here's some examples of hooks. For example, in the instructions, you may define the role, how the LLM should behave, like always answer like a logical mathematician. Tool hooks, you might attach a web browser, a calculator, or an API. When the user asks for critical values, use this tool. Restrict the documents, only consult lecture notes in this PDF. That's a very useful one for students wishing to use LLMs for their coursework. And APIs for dynamic tasks like real-time stock prices and so forth. I was using my Jeeves persona when I was getting some help on building this slide, learning about hooks and making some slides about it. And Jeeves made this for me, which I rather liked, so I'm going to present it to you. Using hooks to customize an LLM is like hosting a dinner party. Hooks are instructions are like the dress code. Tools are the waiter who fetches items from the kitchen. Files are the recipe book on hand. And the API is a phone you use to call a specialist chef when guests ask for sushi. Very good. And finally, in the terminology section, get on to rate limits. This is what I found very frustrating when I tried the free version of Claude. I came across the rate limit almost immediately and I couldn't get another prompt until 7 p.m. that day. So these are imposed by LLM deployment platforms to regulate the throughput over time. Okay, they're nothing to do with the token size, context windows. They're something else. But they are measured in tokens per minute, rather than a size of a context window. Or it could be the number of calls per minute, it could be the requests per day. It doesn't have to be measured in token. Different providers have different ways of measuring their rate limits. Claude measure them in tokens per hour, or I can't remember exactly. Maybe it's tokens per minute. I think it might be 8,000 tokens per minute. Rate limits govern how often and how much total information that you can exchange over time. It's different to the context window, which defines how much information the model can consider at once to shape its response. The rate limit's about the information exchange, and the context window is how much the model can see. Okay, so stop share, and that's it for this part 3.